Once again, this is the Horner Universal I/O Simulator launch. We appreciate you joining us. And as always, you have the opportunity to ask questions. We have a Q&A tab where you can post those questions, and you can do that throughout the program. You don't have to wait until the very end. We may be able to answer them before the end, actually. There's also a chat section. Feel free to chat messages if you like, but generally the better place to put questions are in the Q&A. But if you accidentally put it in the chat, we'll find it and we'll make sure we get it answered. Okay, why don't we go ahead and get started? It's about 2 minutes past the top of the hour. So today we are covering the new Horner Universal I/O Simulator. So we're covering that and a variety of other topics. Let's take a look at our agenda. Again, we're going to spend a bulk of our time on our new I/O Simulator product. Hopefully you'll find that useful. I know I'm excited about it as a longtime applications engineer. We'll talk about what it is. We'll talk about its features and functions. We will take an opportunity to give you a little bit of a product tour and a demonstration through some videos we recorded this morning. And then we have some other topics we'd like to discuss with you, including our first ever Horner OCS Online Training course. We've announced that, and I want to review the format for that training to try and answer any questions you may have. We're also going to talk about a new academic program that we've launched recently, which gives college students and colleges in general the opportunity to get educational discounts for lab equipment and senior project type equipment, whatever is needed in that environment. And then, as always, we'll take time at the end to answer any questions that don't get answered during the program. Okay, the new Horner Universal I/O Simulator. What is it? So this is a new tool for applications engineers, also useful for technicians, for students. From an application engineering standpoint, anybody who is designing application code for machine control, I think will find this a very useful accessory, because what it does is it allows you to very easily simulate the inputs and outputs, both digital and analog, that you're going to be connected to, your machine will be connected to for your application. And of course, there's certain things that you can't simulate with a simple I/O simulator, but this is a pretty good one. So we think it will be very useful. And as I mentioned earlier, for those who are students, it gives them an opportunity to turn their dorm room or apartment into a lab that they can use whenever they want. Okay, so that's, again, part of the usefulness of this product for that audience, whether it's part of the academic program or just purchased independently. Okay, so the I/O simulator is actually a kit. And what does it include? Well, it includes the unit itself, which you see there on the screen. It includes a 24-volt DC power supply, good enough not only to power the simulator, but also just about any OCS that we sell. And then it also includes some special I/O cables that allow you to connect to any Horner OCS All-in-one Controller, or even to a traditional PLC or remote I/O module. It really is not specific to a Horner product necessarily. Now let's take a look at the physical construction of the I/O simulator. I think it's a good size. It's not too big, not too small. It's about 4.5 inches square. The tallest component is a little more than 2 inches tall. And things are big enough where it's pretty easy to use the knobs and the switches that you're going to use to, to simulate your actuators and your sensors in the field. There's really only one specific operator that needs to be operated with a screwdriver. Everything else is pretty easy to use by hand. Now, in terms of where you use it, it's pretty versatile. You can sit it on your desk, which is what a lot of us are going to do. You can snap it on DIN rail if you have some other DIN rail equipment that's handy around your desk or your work area. That's a great option because it really helps stabilize it completely. You can also screw it to a surface if you want. And if you decide to remove it from your case, you can mount it permanently using standoffs. You could even snap in some rubber feet if you wanted. So it's pretty versatile in terms of how you mount it, or if you mount it at all. All right, when we take a look at the digital inputs, this is pretty straightforward, right? We've got 8 switches. Now, we decided to use slide switches. Slide switches allow you to simulate both a maintained as well as a momentary type switch, depending on how you actuate it. So that's obviously important because certain types of Certain types of sensors in the field are going to come on and stay on. Other ones are going to be on and released depending on the application. And the switches are effectively compatible with any 24-volt DC positive logic input modules, the same kind you'll find on an OCS, for instance, or your typical PLC for that matter. On the output side of things, we've got 8 LED indicators that will allow you to check out and verify that the outputs that you're expecting to come on are coming on. And these are compatible with your typical 24-volt DC positive logic or sourcing output modules, the most common today by far. Now, this is not limited to strictly switches and lights. We're doing a lot more than that. So on the high-speed counter side of things, we've got an encoder component, which allows you to either simulate a full encoder with quadrature type simulation, or you could use it to simulate a totalizing type application where you're outputting, where pulses are coming in and you're counting those. And again, it's compatible with 24-volt DC positive logic type signals. Now, we don't want to leave out process applications. So one of the things that I discovered when I was researching for this product is that there are not a lot of I/O simulators these days that offer 4 to 20 milliamp type simulation. You can find them, and there are some that are like battery powered, which you can effectively, that are just used for 4 to 20 milliamps. But most PLC manufacturers that offer any kind of simulators, for the most part, they're voltage type units where you're going to adjust a pot and see a change in a voltage, which is effective. But again, 4 to 20 milliamps is by far the most common sensor type out there. So it makes sense to simulate that directly. It also prevents you from having to change your I/O configuration from the point at which you are doing your testing to the point at which you need to put something in the field. If you do have to make a modification to your I/O configuration, that's another opportunity for an error because you could forget to do that, for instance. So again, we've got 2 4 to 20 milliamp outputs that are compatible with just about any standard 4 to 20 milliamp input modules. Now, not to leave out temperature sensing as well. So we do have a pot that does require a screwdriver to operate that can simulate an RTD PT100. So if you've got a temperature control application with RTDs, certainly not a problem. You can use this pot to simulate changes in temperature as you go through and test your code. And then if you have analog outputs in your program that are going to be used, let's say, to control the position of a valve or maybe to control a heater through an analog signal, whatever the case might be, then what we do here is we allow you to connect up your 4 to 20 milliamp output, at least one of them, from your controller. And then you can apply some test leads to a couple of test clips and then use your multimeter to verify that the output level, the milliamp level, is what you would expect based on your program. So it does require a multimeter, but it's a pretty common approach to solving this without adding a lot of cost, which would make the product expensive. And the more expensive it is, the less people will be able to take advantage of it. Okay, so let's talk about how you actually connect this guy up. It's pretty straightforward, but I think we should cover that. First of all, we include a 24-volt DC supply, a plug-in-the-wall type, that has enough oomph to basically power any OCS, and it plugs in with the barrel connector. Now, one of the things that keeps this simulator cost-effective and also universal is the fact that it doesn't come with pre-wired wiring harnesses. What it comes with is an I/O cable that connects on one end to the simulator, and on the other end can connect effectively to any OCS All-in-one Controller, any PLC, any remote I/O block. And to make the connections quick, all the ends of all the cables, in addition to being color-coded, so it's easy to tell which signal is which, all of the signals are connected to ferrules or terminated with ferrules, which means no stripping of wires, keeps things really straightforward, really easy. Okay, so since we've kind of gone through and hit the highlights of the product, let's go ahead and take an opportunity to give you a little bit of a product tour from a video that I recorded this morning. Okay, let's take a product tour of the new Horner Universal I/O simulator. So it's pretty compact in size, as you can tell from my hands as well as from the screwdriver to give you some scale. It's about 4.5 inches square. Not exactly, but pretty close. You power it from this barrel connector. All right, so, and we do include a 24-volt supply, a wall type supply that's powerful enough to power pretty much any OCS along with the simulator. It also includes a variety of operators for simulating both digital and analog I/O, and let's kind of go through those. Okay, so first of all, we've got 8 slide switches. Now, slide switches are important because with a slide switch, you can simulate either a momentary switch or a maintained switch. So it's important that those are slide switches. Push buttons would not allow you to emulate, for instance, a maintained type operator. Now, for checking to see that your outputs are turning on when they're supposed to and in the sequence they're supposed to, we've got 8 LEDs lined up here. These are nice and bright. Of course, you can't see that now because they're powered down. For simulating analog equipment, we have these two 4 to 20 milliamp outputs. Now, it's pretty unusual to actually have true 4 to 20 milliamp outputs in a simulator, but we've done that here with these 2 pots. Very convenient. Now, for temperature inputs, you can simulate an RTD PT100 with this pot here. As you can see, that's operated with a screwdriver. Now, for simulating 4 to 20 milliamp outputs, we have some test leads. Let me show you those. Okay, those are right here, and you can use your test lead to clip on here, positive and negative, and you'll use these in conjunction with your multimeter to check to see that your 4 to 20 milliamp output signal is at the level you expect based on what you're simulating at the time. Okay, so that's for simulating outputs on the analog side. Now, we haven't forgotten about high-speed inputs, you know, whether you're looking for a pulse train or for just a few pulses for counting or an encoder type signal. We've actually got the ability to emulate that or simulate that here with this encoder knob. So whether it's totalizing application or whether it's a positioning type application, you can manipulate this encoder to help you test your logic there as well. Now, I mentioned this is a pretty universal simulator in that you can connect it to just about anything. You've got these 2 cable connections here, okay, and they kind of look like ribbon cable connections, but they're definitely not. What we have are 2 cables, like you see here, 2 jacketed cables that are included in the kit. You can see every conductor is color-coded, so it's easy to tell what signal does what. And you'll also notice that every signal is terminated with a ferrule. So that means you're not going to spend any time stripping wires, and because it doesn't come with terminal plugs attached on the other end, you can use this with any OCS, any I/O module, whether it's a remote I/O or what have you. You can even use it with a third-party PLC. So it's really handy, and the fact that these cables come unterminated helps make it even more universal. Now, I mentioned before that it comes with a power supply. Here's an example power supply. It may not be the exact one we're included, but a similar one. And again, we're making sure this supply is powerful enough so that it'll power just about any OCS that you want to have powered up in your desk. Okay, so I think that's a pretty good run through of the hardware. So once again, it's about 4.5 inches square. You can mount it on your desk, you know, just set it on your desk. You can mount it on DIN rail, whatever's convenient. So use it to help you simulate your applications, to help you test your logic before you get in the field. Okay, so that's a quick product tour, if you will. Next, I have a short video where we see it in action. I think you can imagine what it does, but let's take a look at that anyway. Okay, now let's take a quick look at how the simulator works in action. Obviously, very simple demo here. I've just got pilot lights on the screen to indicate the status of the digital inputs. I have push buttons on the screen so that I can turn digital outputs on and off. I have bar graphs that are showing me the current value of the analog inputs in terms of counts from 0 to 32,000, which is the scaling for those. And then I have an encoder position that I can monitor as well for high-speed counting. Now, in my case, I'm using a XL7 Model 3, so there isn't any analog outputs and there's no RTD support. So I'm not taking advantage of those particular capabilities of the simulator. Okay, so let's take a look. First of all, I've got these switches that I can exercise to verify, or to simulate, obviously, things like limit switches and photo eyes and push buttons and those sorts of things. I can turn them on and leave them on. I can make them more momentary, whatever the case may be. Okay, pretty straightforward there. In my program, as I turn digital outputs on and off, we can see the LEDs turn on in the simulator here. Okay, so you can see those are pretty bright, so fairly easy to see there. And then let's take a look at the analog input side of things. So on analog input 1, as I adjust the pot, you'll see my analog input value changing, going towards minimum, and then going to maximum. Okay, same thing for the second analog point as well. Okay, and then on the encoder side, this is an encoder, a free spinning encoder type wheel. So as you see, I go up and down. Well, in this case, I guess I have it configured for just, I have it only configured for totalizing. So in this case, I'm just totalizing as I go. There's no, position of moving up and down. So I think my label there is a little bit of a misnomer. This is really just counts that I'm generating into that particular register. Okay, so that's just a quick look at the I/O simulator and how you can use it to simulate digital inputs, digital outputs, analog inputs, and in this case, high-speed counting for totalizing. Okay, so that was a couple quick video looks at the product. We've got some good questions so far that we'll go ahead and cover. We've had our product tour and our product demo. John asked, is it easy to daisy chain multiple units? For instance, could I utilize 2 of them to take advantage of all the I/O that's built into a Model 4 OCS that has 24 inputs and 16 outputs? Absolutely, you could daisy chain them. Let me go ahead and I will say that what we'll do is we're kind of finalizing the product documentation now. I'll make sure we include instructions on how to use multiple units with the same application, because I could absolutely see people wanting to do that. So yes, it is capable of that. Of course, it'll be up to you as to how easy it is. It doesn't have a specific port on it for daisy chaining, but I think it's pretty straightforward to use multiple ones in the same application. And we'll definitely include that in the documentation. That's a great idea, John. I have another question from another John asking if it can handle high voltage as well as low voltage digital outputs or just dry contacts. So, I mean, from a digital I/O standpoint, the outputs from the simulator are effectively just 24 volts based on the position of the slide switch. And then the simulated outputs are just 24 volt outputs from the controller into the simulator to light up the LED. So there's nothing high voltage there. It's all pretty much 24 volts DC, both in and out. Couple good questions there. And if there's anybody has any other additional questions at the end, we'll go ahead and make sure we cover those as well. Let's go ahead and talk some more about some more commercial details. We've seen all the technical details. Let's talk the commercial details. Okay, so again, what's included in the kit is the simulator unit itself, a 24 volt DC power supply, and the universal I/O cables that I showed you that have ferrules on the end, so you can connect them to whatever I/O family that you choose or whatever I/O unit you choose. The part number is, you can see there on the screen, the HE-TK001, and it has a list price of $197. So we think that's a pretty good price. $197 includes the simulator and all the cables and the power supply, and we think it's a pretty useful component for sure. And then this will be shipping starting next month. So something to be aware of there. Okay, so now that we've covered the I/O simulator, let's talk about another topic that we want to introduce to you today, and that is the fact that in the fall, in October, we are going to be offering our first online training class. Now, this is not as a replacement for in-person training. Our in-person training has always been really popular, and we've got an in-person training class in September that has been popular so far. We've only got a couple seats left for in-person training, but we thought it was a good opportunity to also offer our first online training course. And one thing that we're going to make sure happens with our online training course is this is not simply just watching some videos and answering some questions. We want to make sure that our online students have the opportunity to get both classroom type content as well as one-on-one type sessions and very extensive hands-on labs, just as if you came to Horner itself, okay? And unlike in-person training, so I guess this would be an advantage to online training, any lab equipment that you're using during your training course is yours to keep. So when you come in for online training, we love to have you. We have some great lab equipment, but of course, when you leave the course, you leave the lab equipment behind. With the online training, you're going to have the advantage of basically being able to keep it. Okay, so in terms of the schedule, the class is scheduled for October 12th and 13th. Now, normally for our in-person course, that's a 2.5-day course. So what we've done is we've compressed it somewhat down to 2 full days. Registration is open, and it will stay open through the end of September while seats are available. Now, we will be teaching both variable-based ladder logic and register-based ladder logic. So regardless of which style you choose or which style you prefer, you'll have the opportunity to use that particular method. They're frankly not that far apart from each other, and we feel like it's really important that we train using variable-based in addition to the register-based ladder logic style. Okay, so again, you have the choice of which one you want to use in your labs for your equipment. So here's how the schedule looks for it. The week before the class starts, you'll receive your training materials through a shipment, typically with UPS, I'm guessing, okay? And in that shipment, you're going to get one of these universal I/O simulators that I talked about. You're also going to get an OCS cable kit that will allow your computer to connect to your OCS controller. You're going to receive hard copies of the training manual, which you would get if you were in person. And you're going to need an OCS. And you can either use an OCS that you've already got, if it's one that we can pre-approve, one of the models that makes sense, or you can take extra advantage of the opportunity and get an OCS, a new OCS at 50% off. And we're offering that for basically any of the micro series as well as for the mainstream XL series products. So that's a great deal. Not only do you get the simulator, the cable, the training manual, but you have the opportunity to buy an OCS at half price, which is always a good thing. Once you've received your training materials, then the week before the training starts, you'll actually schedule an appointment for a one-on-one online session. So it'll just be a few minutes, more than likely, to be one-on-one with a phone call, an online phone call, with one of our instructors who will help you verify installation of the software. And if you need any wiring advice at all in connecting the I/O simulator to your specific OCS model, we can provide that at that time. That way, before the class even starts, Seascape is installed and connected to your controller, and your wiring is all complete. And the wiring only takes maybe an hour at most to wire up an OCS to the I/O simulator. I did 2 of them this morning. I wired up to a XL series OCS in about 10 minutes, and I wired up to a micro series OCS in about 10 or 12 minutes. And that was including, using wire ties to neaten up the job. So it's not very difficult at all. Having those ferrules pre-installed in those cables makes it really simple. And the color coding on the cables also is really straightforward. Okay, so the week before, you're basically going to be all set. Now, what are we going to be covering? It's going to be just like you were in person from a material standpoint. Okay, and just like in person, we have a quick introduction. Usually it's about a 30-minute presentation where we introduce our students to who Horner is, and we introduce our products, including our Horner OCS All-in-one Controllers. Then we'll have a review of the software setup process, which really should have been handled the week before, but we'll review that. And again, you'll have the opportunity to use Seascape directly during that review. And then after that, we've got configuration and programming. Sorry, the programming is covered up there, but configuration and programming, screen handling, screen development, timers and counters, move functions, and math blocks. So all that material we'll be covering with not only classroom type material, but we'll also be covering it with labs. And you'll have the opportunity to do those labs remotely. And you'll have the opportunity to, during the lab period, if you need some help, you'll have a chance to get in touch with an instructor to give you some one-on-one assistance during the lab period. Day 2 is a lot like day 2 here at the factory. You'll get an introduction to C-SCAN networking, an introduction to Ethernet networking, and then more on graphics editing, including alarm handling. We're going to cover WebMI, and then also you're going to have remote media and data logging. So a lot of good material, effectively the same material you would get in person, but you're going to get it online, and you're going to have the opportunity to do labs remotely with assistance where you need it. Okay, so let's talk about when the training's done. So what happens when the training's done? Well, you'll receive a Horner training certificate. So this will be a fully certified course, okay? You'll get an electronic certificate right away at the end of the course, and then in the mail, we'll send you a hard copy like you see there on the screen, okay? And then the good news is, again, once the training course is over, you've had the opportunity to purchase an OCS at half off. You've got the OCS, the Horner programming kit for connecting to your OCS in a variety of ways, whether that's USB or serially or via Ethernet, whatever the case may be. And you've got your handy dandy IO simulator that you get to keep so that as you develop more applications and develop more logic, you can use that to test that out. So it's a real advantage to be able to take this stuff home or keep it as opposed to sending it back. Okay, so the details are, again, the class October 12th and 13th. Register now through September 30th while seats are still available. $497 per seat, okay, is the price. So it's a little higher than our in-person training for a couple reasons. One is you've got more equipment you get to keep. And secondly, even though the cost of the class is a little bit higher, the total cost to your company will probably be less because of less travel costs, right? So it's a little higher on the tuition side, but you get some equipment plus the opportunity to buy half off OCS, and you don't have any travel costs. So if you have, management says, we just can't afford to send you to Horner training this year, maybe they can afford the online version. And again, it includes all your materials and equipment except for the OCS, which you can buy at half off. So here is I've got a few questions. I'm just going to go ahead and pause now and get those answered. Let's see. If we sign up for the online training, does the simulator ship soon or shortly prior to the class? So what we will do is the original plan was to send the equipment the week before. However, by request, we like to be flexible here at Horner. If you have a request that you would like to receive the equipment early, then I'm sure we can make special arrangements. Okay, so you can take advantage of that simulator even before the training cost. So by default, you're going to get the equipment a week before the class, but if you would like to get it early, we will work with you to make that happen. Here's a question, and this is on the simulator from Bob. He says, with a single barrel connector, how would a power supply feed both an OCS and the simulator at the same time? Good question. So the way that works is you have 24-volt DC coming into the barrel connector, and then there are multiple conductors on the cables that leave the simulator that have 24-volt DC on them. There's one that you can connect to the 24-volt power plug on the OCS, and another one that you can connect to the V external pin for the outputs. Because keep in mind that when you're firing DC outputs, for instance, you're going to need to have DC voltage to send to the outputs. So coming out the cables, you've got two 24-volt conductors, one to power the OCS and the other one to power the outputs. Good question, Bob. And then the next question from Mark is, will the OCS have the latest Seascape installed or shipped with it? So I think what he's really meaning to ask is, will the latest version of Seascape ship with the equipment that gets delivered the week before? I hadn't really thought that far ahead. one thing I will say is absolutely you'll be able to download the software, the Seascape software online for sure. Okay. If that's a problem for you, just make a request and we can include Seascape on a thumb drive, but I don't think that's the current plan. However, if what you're asking about is, will the OCS have the latest version of firmware on it when it's shipped? If we're talking about firmware, then generally it should, yes. It should have a plenty new enough version of firmware that you can use it for the training course. If you're going to use an OCS that you already have, I suppose there's a possibility, if that's a model that makes sense, there's a possibility that we may recommend that you go ahead and update the firmware on a unit that you've had for a while. But in general, even for that, I don't think it's necessarily likely, because for the basic functionality that we're talking about for the training, programming, graphics development, data logging, WebMI, generally, as long as your firmware is less than a couple years old, you'll probably be fine. If it's not, then we'll have you update the firmware. Okay, so there's some questions that we've got covering both online training as well as the simulator. Next, I want to talk about Horner's academic program. Now, many of you who are attending are probably not students, you're probably not professors or other professionals at a local technical college or university, but this is a program that we've rolled out recently that we think is important to let folks know about. Because even if we're not students ourselves, at least not in the official sense of the word, we very often know students. And we know students who are in the process of learning about controls, learning about electricity, whether they're electrical engineers or technicians, whatever the case may be. And I know that we hear quite a bit from students who are looking for a good way to do their senior project, and they don't have a great method of getting equipment at an economical price, especially if we're talking about industrial automation. So our new academic program will address that particular need and some others. So what we're doing is we're offering lab kits and OCS controllers at an educational discount. So from a tech school standpoint or a college or university standpoint, we're now giving them the ability to provide their students, probably through the book program, with personal lab equipment. Certainly something that was a problem during the pandemic was the fact that a lot of labs were shut down because of social distancing. While we're starting to come out of the pandemic for sure, there are some real benefits to students having lab equipment that they can use in their dorm room, in their apartments, wherever they are. And so we're offering these lab kits to give them that opportunity. And for universities that want to utilize the Horner equipment for their controls labs, and we have several already that do that, this provides even a better opportunity to allow their students to purchase through their book program a lab kit, which they can use during the lab and then which they can keep. So kind of like our online training, now students have real equipment that they can work with and play with once their class is over with. So that's one advantage, providing lab kits to tech schools. And the other is something I already kind of mentioned, and the fact that a lot of engineering students and technical students have senior projects that are a requirement for graduation, and they need to acquire the equipment to do those senior projects. And a lot of them are limited to things like Raspberry Pis and those sorts of things just because of cost. And there's nothing wrong with Raspberry Pis. If you are doing a firmware type project, that's a great approach. But what if you're a engineer who specializes in electrical controls? It makes a lot more sense to use a traditional PLC type product, or in this case, an OCS All-in-one Controller to complete that senior project. And we've got, again, special prices for controllers and other equipment that they may need. The simulator could be a piece that they're interested in as well to help them with that senior project. Now, it does require pre-qualification. So for institutions at the college level, the university level, they will need to get in touch with a Horner regional salesman to kind of pre-qualify their institution for equipment purchases. And in the case of students, it's very simple. If you're a student and you're interested in purchasing an OCS for a project, a class project, really all we need is an educational email address that we can verify the fact that you are a student. So if we have that information, then we can very quickly pre-qualify students to purchase equipment as well. So this is a great new academic program that we're really excited about. We just rolled it out with our sales channel last month, and we've got these handy dandy little flyers. It's more of a postcard, I guess, if you will, that we're in the process of preparing to send out to a whole variety of our sales channel partners as well as universities to give them the opportunity to purchase these products. So I got another question from Mark. He asked if there's any veterans discounts available. Well, that's a great idea. We don't have anything official at this time, but that's certainly something we should consider. No question about that. Especially for, we appreciate all the veterans, don't get me wrong, but especially those veterans that are in the process of maybe acclimating into the work environment after, getting out of the armed services. That would be another great expansion, I guess, of kind of the student portion of the academic program. So that's definitely something we'll consider. And thanks for that idea, Mark. Appreciate that. So at this stage, we've answered a lot of questions. Does anybody have any additional questions? Anything else that came in? Casey Gardner is joining me today. Casey's one of our sales applications engineers. Did you see anything else, Casey, that we need to cover?
I don't believe so. We did just get Phil's official statement in the chat as well, that we will support veterans with the educational program, and we appreciate all their sacrifice. Absolutely.
Awesome. That's a benefit of having the owner of the company attending the webinar and quickly being able to act on suggestions from customers. So another advantage of attending a webinar is you get to get feedback directly to the guy who can make it happen. Fantastic. Marcy, we also have Marcy Tyree joining us. Marcy is our marketing person extraordinaire. So anything else that we need to cover today, Marcy?
I don't think so. I think you got it all.
Okay. So again, if anybody has any quick questions, don't hesitate to type them in. Oh, here's one that just came in. Yep. Is there a simulator for CAN bus networking? Thinking about the mobile market. There are simulators for J1939. And J1939 is a CAN protocol that we're going to be covering in a live event this upcoming Tuesday. So that's a really good segue, but I'll go ahead and answer the question now. There certainly are commercial simulators available for J1939 networking. I'm not aware of simulators for CAN Open, for instance. However, if you have multiple OCSs, multiple OCS All-in-one Controllers, then you can simulate both C-SCAN as well as CAN Open. And then if you want to simulate J1939, there are commercially available J1939 simulators that range in price from a couple $100 up to a couple $1,000, depending on the specific requirements that you have for your simulation. So we don't sell those directly, but those are available commercially for sure. And if you have if you're looking for a specific recommendation, feel free to email either myself, chuck.ridgway@heapg.com, or casey.gardner@heapg.com, and we will make some specific recommendations for you. Don't forget that in addition to our monthly webinars, we also have live streams every Tuesday at 2 o'clock. In our live streams, we typically tackle a pretty technical topic. It's usually, again, related to a technical subject that we will cover in a fair amount of detail, and we try and throw in a lot of product demonstration to keep it fairly informal with lots of question and answer. The July schedule, we're obviously halfway through July approximately, and we've just covered Seascape security and user-defined function blocks. There we go, J1939 protocol coming up this upcoming Tuesday. And then we're going to talk about the specifics of analog I/O with the micro OCS at the end of the month. And then we'll have a full schedule for August as well. Again, all these are available live on Tuesdays on YouTube. And of course, you can always watch them on replay. And then the J1939 protocol, again, that's our topic that we'll next be covering in the live stream format Tuesday on YouTube. And you can also register on our website if you'd prefer to attend those events in Big Marker, which is our webinar type platform. Okay, so once again, I want to thank all of you for joining us today. We appreciate all your feedback and the great questions that we received. And we look forward to seeing you again for our next event. And everybody stay safe out there.